Hi, I'm Dave McGowan. I'm an R&D engineer at Agilent Technologies, and something I'd like to show you today is debugging techniques for low power processors. What I have here is a Texas Instrument MSP430 development tool, and this particular tool has a radio in it. So what we're going to be analyzing is the current of its low power modes and the radio. How we're going to do that analysis is with this instrument here. It is an Agilent Technologies N6705B DC Power Analyzer. And what we have here is we have the analyzer hooked up to the MSP430, and it is simulating the battery. These things are powered by batteries. And so what we're going to do to run the test, we're going to start the data logging software, and then I'm going to use this analyzer to simulate the battery to turn on the processor, and then we're going to collect current readings, and then we're going to analyze those current readings when we're done. So in order to run that test, I come over here and I start the data logging process, and we will turn on the system. Now that we've collected all the current measurements, let's look at some annotated data around that. So what we're seeing here is the current profile of the test we just ran. What you're seeing is we have lights that are blinking, we have watchdog timers that are triggering, and then we see a radio come on. And if you look at these big spikes are the places where lights are coming on and off. There's a red and a green light. And the little spikes is where the watchdog timers are coming on. And in low power processor programming, you tend to go to sleep a lot, and you use watchdog timers to check to see if you need to do anything. In this particular test, you'll notice that we're actually measuring about 450 nanoamps at these low levels. That's what low power mode 0 is, low power mode 3. But when we flash a light, we're actually in the 1.5 milliamp range. And so what you're seeing here is that this analyzer is able to handle 3 orders of magnitude in measurements. And that's important for these types of applications. And in the middle there, you see where the radio comes on. And there, you're also seeing, even though that radio is on, we can still see the watchdog timer clicking after the radio has come on. If we go to how we use this data, if we go to the Texas Instruments data sheets, you'll notice we can use the tool, and we made these 3 measurements to verify that we were in low power mode 0, low power mode 2, and low power mode 3. So what we have here is a tool that allows us to look at current and help us determine what low power modes we are in. As a firmware developer, it's important to understand your low power modes. This Agilent solution gives you visibility into those low power modes. Thank you for watching.